All right, let's just dive right into it. We're looking at a brand new, absolutely groundbreaking study straight out of the journal Nature, and it is totally rewriting the rulebook on how and exactly when the Antarctic ice sheet is going to melt. If you follow climate science even a little bit, you know sea level rise is the massive elephant in the room. But the exact timeline? That's always been the missing piece of the puzzle. Well, today we're unpacking how the ice is actually giving us a remarkably precise timeline. Now, to grasp why this is such a huge deal, we really have to look at what's at stake here. The IPCC has been warning us that under high emission scenarios, global sea levels could shoot up by over 2 meters by the year 2100. 2 meters! That is, actually, scratch that. Catastrophic doesn't even cover it. We're talking about threatening hundreds of millions of people globally, wiping massive areas of sovereign territory right off the map, and putting a full quarter of all Australian homes straight into flood zones. The sheer scale of it is just hard to even wrap your head around. So that brings us to the multi-trillion-dollar question. Can we predict exactly when this ice is going to fall into the ocean? Because honestly, the exact timeline has always been this huge blurry question mark. It's been the biggest roadblock for governments trying to actually prepare. But this new study, led by researchers at Monash University and Securing Antarctica's Environmental Future, or SAEF, they're asking if we can actually nail down a reliable forecast, rather than just guessing.
Part 1. The predictability plot twist.
Get ready for a massive scientific plot twist, because this fundamentally changes our near-term worst-case scenario. Dr. Felicity McCormick, the lead researcher on the study, puts it like this. If ice sheet models accurately reproduce the rates of ice loss we observe today, we can have confidence in using those same models to reliably predict Antarctica's contribution to sea level rise over the next 30 to 50 years. What her team is revealing here is that we literally have a highly predictable 30 to 50-year window. This effectively completely rules out the IPCC's absolute worst-case sudden collapse estimates for the immediate future. The rate of loss we're seeing right now, it turns out it's a rock-solid predictor for the next few decades.
Which leads into part 2. Ice sheets have memories.
So, how is this level of prediction even possible? Well, it all comes down to this absolutely fascinating physical property called reservoir time. You can think of reservoir time like a giant time capsule. It's an ice sheet's memory of past climate conditions. It basically dictates how quickly a glacier basin is going to respond to changes, like a warming ocean, before it really starts to accelerate its melting. In plain English, an ice sheet holds onto its memory for a specific number of decades before it fully reacts. The snow that fell thousands of years ago leap inland takes a really long time to work its way out to the coast.
And the crazy part is just how fragmented this ice memory is across the entire continent. When you break down the numbers, it is wild. The Antarctic Peninsula has an incredibly fast reservoir time of just 11 years. The Amundsen Sea sector, which is currently melting faster than anywhere else, is sitting at 53 years. But then look at East Antarctica, 330 to 485 years. That means the peninsula is going to react to today's climate very soon, in just over a decade. Meanwhile, those deep, massive basins over in East Antarctica, they are literally still carrying the imprint of snow that fell centuries ago. They won't fully respond to today's heat for hundreds of years. Because of these undeniable, stark differences across the different drainage basins, the ice loss over the next few decades isn't just some random chaos. It follows a highly reliable, mathematically predictable pattern that scientists can actually map out. The near-term melt is just a direct function of these varied but known reservoir times. But, of course, there's a catch. Part 3, the 2080 cliff edge. So, before the year 2080, we have this highly predictable, constrained near-term ice loss, driven by those memory banks we just talked about. But post-2080, we enter an era of deep, dark uncertainty, where all that nice, linear predictability completely shatters. Around the year 2080, the reliable relationship between today's melt and tomorrow's sea level rise basically falls right off a cliff. By the time we hit 2100, that predictable relationship is pretty much entirely gone. So why does it break down so abruptly? Well, it's because chaotic feedback loops start taking the wheel. We're talking about massive factors like marine ice cliff instability, or MISI, major shifts in subglacial hydrology, warm seawater pushing its way deep under the ice, and the rapid retreat of ice that's resting on bedrock below sea level. Once that below sea level ice starts pulling back quickly, it is almost physically impossible to stop or reverse. These wild feedback mechanisms don't really register right now, but late in the century, they can trigger massive accelerations in ice loss that our current models just fundamentally struggle to forecast accurately. Which brings us to the final takeaway. Part 4, our window to act.
The absolute most crucial point here is that we now have a clearly defined roadmap for the next 3 decades. The science has essentially bought us a very specific window of time. As Professor Stephen Chown, the director of SAEF, points out, the predictability identified in this research does not reduce long-term risk. Instead, it provides a defined period in which to act with greater confidence. To be perfectly clear, this predictability is absolutely not an excuse to kick our feet up. The long-term risk hasn't magically vanished. We just finally know exactly how much time we have on the clock to prepare for it.
So how do we actually use this 30-year window? Well, scientifically, we need to use this time to improve our observational systems and build better ice sheet models so we can eventually figure out that post-2080 chaos. But on a human level, this predictable 30 to 50-year period gives governments the hard data they need to make life-saving decisions right now. For highly vulnerable populations, like folks in low-lying Pacific Island nations or places like the Maldives where the ocean is literally already lapping at the main roads, governments can use this timeline to plan critical infrastructure, figure out land use, and even map out coastal relocation strategies. We have a regional responsibility to use this head start.
The ice has literally given us a 30-year warning. The real question is, will we listen? We have the data, we understand the reservoir time of the ice, and we know exactly when the models are going to go completely haywire. The ball is entirely in our court. But consider this. If the ice remembers the climate from centuries ago, what will it remember about us? If your mind was just blown a little bit today, hit that like button and subscribe so you don't miss out on more bizarre history, weird science, and untold facts. Drop a comment below with the most surprising thing you learned. Check out the videos on your screen right now for another deep dive. And remember, stay curious, and I'll see you in the next video.